So in this video, we're going to go over some more complicated types of quadratic equations where we can use the square root method, okay? In all of these, you're going to have a binomial to the second power, and in order to not have to expand that binomial or square this binomial, we're going to actually use the square root method in the first step, okay? Or once we've isolated that binomial that's being raised to the second power, okay? So in example 3a here, the first thing I can do is I can take the square root of both sides right away, okay? The square root of this binomial squared is going to give me x plus 2, and the square root of 16 is plus or minus 4, okay? So now I'm going to subtract 2 from both sides, okay? So, excuse me, let's go ahead and break it down. Is x plus 2 equals positive 4, or x plus 2 equals negative 4, okay? Now I can subtract 2 from both sides, and I'm going to get my two solutions. So x equals positive 2 over here, or x equals negative 6 over here, okay? It's always great when you're solving any kind of equation, but specifically these quadratics. If you plug 2 in here, you get 2 plus 2 is 4, 4 squared is 16. So this is obviously a solution. When I plug in negative 6 plus 2 is negative 4. Square that, you also get 16. So you can see both these solutions are true. They make the equation work, okay? Now in B, we don't have our binomial to the second power isolated yet. So I'm going to add 2 to both sides first, okay? Once I've done that, then I can use the square root method. I'm going to take the square root of both sides, okay? So that's going to give me negative 2x plus 5 equals a plus or minus 11, okay? So let's break this down into two equations. Let's say negative 2x plus 5 equals positive 11, or negative 2x plus 5 equals negative 11, okay? So now we've got two basic linear equations we can solve, okay? So on the left here, I get negative 2x equals positive 6, okay? On the right, I get negative 2x equals negative 16, okay? Solve this one, that gives me x equals negative 3, or x equals positive 8, okay? Again, plug these values back into your original equation, and you'll see that those are the solutions, okay? All right, so pause the video here. We've got 4 more examples here, C, D, E, and F. Give those a try, and then come back and save your work, or check your work. It looks like we're going to have some with imaginary solutions, okay? So just be aware of that. It's okay to have imaginary solutions. Just make sure you're dealing with those correctly. All right, in problem C, we're going to add 2 to both sides first, okay? Now we're going to divide by this 2. We got to get rid of that 2. Okay, so I get x minus 1 squared equals 4. I want to take the square root of both sides. So that gives me x minus 1. I'm not sure why that plus is there. Okay, equals plus or minus 2. All right, so x minus 1 equals positive 2, or x minus 1 equals negative 2. All right, when we solve this equation, we get x equals positive 3, and the other solution would be x equals negative 1, okay? Feel free to plug those back in here. You'll see that both those solutions are correct, okay? In D, I'm going to subtract 3 from both sides first. Then I'm going to multiply both sides by 3 to get rid of this coefficient here, 1/3. Multiply both sides by 3, and I get x plus 6 squared equals 81. So we'll take the square root of both sides. That gives me x plus 6 equals plus or minus 9, okay? So let's break this into two separate equations. X plus 6 equals positive 9, or x plus 6 equals negative 9, all right? So on the left here, I'm going to subtract 6 from both sides, so I get x equals 3, or I get x equals negative 15, okay? Again, always check your work. Plug 3 in here, plug negative 15 in here. You'll get a true statement here. So both of our solutions are correct. All right, last two. Add 10 to both sides first. Divide both sides by this 5. Okay, take the square root of both sides. Okay, so that gives me x plus 7 equals plus or minus I. Remember, the square root of negative 1 is I. Okay, so when I subtract 7 from both sides, I don't have to break it down into 2 like I did up here, because I can just go ahead and subtract 7. I get negative 7 plus I as one solution, and negative 7 minus I as another solution. Okay? You can still plug this in and check your work. You could plug -7 plus I here, do the math, okay? You're gonna get that it's a true solution, okay? You could also plug in -7 minus I here, and you'll get the same thing, okay? So these are correct. All right, in F, we're gonna divide both sides by -3 first, okay? We're gonna take the square root of both sides, all right? So on the left, I get x plus 2 quantity squared, okay? I'm going to go ahead and simplify -12 as 4 times -1 times 3, okay? Just like we would simplify any radical expression, we want to break it down using perfect square factors. All right, so that gives me x plus 2 equals a plus or minus. This should be 2i radical 3. Okay, I'll go back and correct that in a second. That should be 2i radical 3, okay? So it should be -2 plus or minus, and again, this should be 2i radical 3, okay? Again, it's a lot harder to check these, but you could plug in -2 plus 2i radical 3 here, okay? And you're gonna get that it's, that works in the equation. And then you could plug in -2 minus 2i radical 3 also in here for x. With a little bit of work, you would see that you get a -12 in here, okay? Once you've squared that, so -3 times -12 would be that positive 36, okay? So these are a little bit more complicated. On an SAT, you might see these answers broken into two. Again, -7 plus I, and then -7 minus I. Here, -2 plus 2i radical 3, or -2 minus 2i radical 3, all right? But that's how you solve a little bit more complicated quadratics using the square root method.